Okay, let us discuss the next problem, problem number 5.22. So this is the problem number 5.22. Just make the diagram and then we will discuss. So you make the diagram. This problem is pretty easy problem. So you make the diagram and then we will discuss. Okay, if you have written, let us discuss the question. So what this question says, so let me read the question. So this question says, find the minimum and maximum deflection angle for a light ray passing through a glass prism with given refracting angle theta is equals to 60 degree. So in this problem, we have to find minimum deviation and a maximum deviation that can be developed through a prism. So I have to find minimum deviation and I have to find maximum deviation. So these are the two things that we have to find. And the angle of prism that is given, that is theta is equals to 60 degree. Generally we assume this A. So this is same as A. So A is given to us. A is 60 degree. For minimum deviation, everybody knows there is an expression, that is sine A plus delta m by 2 and sine A by 2. Now put A equals to 60 degree because prism angle is 60 degree. So if you put A equals to 60 degree this side, you can also put this side. It will come out to be this function you can find, and you take sine inverse, it will come A plus delta m by 2 is equals to 48.59 degree. Now if you solve here A equals to 60 degree, you will find delta m is equals to around 38 degree. So just do your own calculation, you will find this answer. If you have calculator to check it out, I will give you 30 seconds. Okay, I think you have done. Now let us find the maximum deviation. You see, maximum deviation of this ray. So this rays will go something like this. So this is the path of ray. I want maximum deviation. This is possible only if this ray, that is the refracted ray, goes along this surface. Then I will have maximum deflection. Even if I have, this is the maximum deviation of refracted ray. I am not talking about the reflected rays. We are talking only for refracted ray. So what is the angle of deviation for refracted rays? Deflection angle I am defining in terms of refracted rays. So this angle will be maximum only if this deflection angle or the refraction angle becomes 90 degree, that is I2 becomes 90 degree. So you see, maximum deviation occur only if light ray coming from the second phase makes a 90 degree angle with the normal, that is I2 is equals to 90 degree. Are you getting or not? So you can write this one. Now if I apply the sine rule at the second phase, I can write n into sine R2 is equals to 1 into sine 90. That is n into sine R2 is equals to 1 into sine 90. So from here sine R2 is equals to 1 by n. You see here. Sine R2 is equals to 1 by n. So R2 is nothing but sine inverse 1 by n. Now we know in prism R1 plus R2 is equals to A. So if I know R2, what is my target? My target is, I know I2, I want to calculate R2 using the sine rule here. If I know R2, can I calculate R1 using geometry, that is R1 plus R2 is equals to A. So next target is to calculate R1. If I know R1, can I calculate I1? So let us say calculate I1 by knowing R1. So I know R1, that is A minus R2. R2 is nothing but sine inverse 1 by n. So now I know R2, that is R1 is equals to A minus R2. So R1 is A minus sine inverse 1 by n. You write yourself and then we'll discuss. Now if I apply sine rule at this face, are you getting or not? If I apply sine rule at this face, so this is the face, if I apply sine rule at this face, what I will get? I will get n1 1 into sine I1 is equals to n, that is n into sine R1 and this angle R1. So I can apply 1 into sine I1 is equals to n times sine R1. Now sine I1 is equals to n times sine R1. R1 I know, that is A minus sine inverse 1 by n. So this is 1 A minus sine inverse 1 by n. Now if I take inverse both sides, so we will get I1. I1 is this value. Now I have to find delta. So delta is nothing but, why we have calculated I1? To find out the delta, because we know delta is nothing but I1 plus I2 minus A. Now I know I1. I1 is this value. Sine inverse n sine A minus this value. So I1 is this plus I2 I know, that is 90 degree, and delta is 60 degree. A is 60 degree because prism angle is given. This is the 60 degree. So now I know. So this is the I2. This is the A. So I1 I2 I know. So I can calculate delta here. So if you put the value of refractive index 1.5, you can calculate delta, comes out to be 57 degree. You just do your own. I am just waiting for your answer. I1 put the value of A is equals to 60 degree. Put the value of n is equals to 1.5. Use your calculator to find this answer. Sine inverse 1 by n you can find using calculator. A is 60 degree. So you can subtract, then take sine, multiply by 1.5, then take sine inverse, add 90 degree, subtract 60 degree, you will get the answer. I am waiting for your answer. Let us take 1.5 minutes. You don't have calculator? Okay, no problem. Go at home and then check it out whether you are able to do it or not. Even you don't have calculator at home, that is another problem. So leave as it is. You just know this is the expression that gives the delta. If you got the answer, then we can go for the next problem. Did you get the answer? Okay, so let us go to the next problem. Some of you might have got the answer, I think. I have got the answer. This I have calculated using a calculator. In the morning, this is the night time. In the morning I have done, and I am making the video in the night. So because the light every time fluctuates in the morning, so that's why I generally use to make in the night. Okay, we'll discuss the next problem.